All right. So I'm supposed to write a dot product as a matrix multiplication. I assume that was the confusing part.
No, the confusing part
Damn
was
it.
the blanks.
Okay. All right. So, how did you write the matrix multiplication as a dot product, or the switch those words? Reminder to self:
The
go
dot.
back and edit
I
this
just
video to switch those words. Just kidding. I'm not going to do that.
I
Okay. So, how did you write the dot product as a matrix multiplication?
well, I just wrote it as a what is it, a 1 by 3 column times a 3 by 1,
Okay. Seems legit.
and then
So you wrote the vector 145 as a row, and then the vector x, y, z as a column.
yeah.
Cool. Um, this, for reference, is traditionally referred to as the inner product, which is a dot product. Like, those are the same thing. There's there's reasons. Trust me. We'll get to it later. Um, all right, that's good. The matrix A has one row. Oh, they made that really easy for us. I wish I hadn't read that now. We should remove that from the textbook. That's too good a hint.
Yeah.
All right, so the solutions ax equals 0 lie on a, oh, something perpendicular to the vector something. Okay, so let's think about what it would mean for ax to equal 0, right? So if this is 0, oh, I wrote a 0 vector here. Is that appropriate?
Yes. No, it's a dot product.
Yeah, this is weird, right?
Ew. Yeah.
Okay, so on the one hand, if I take this is a 1 by 3 matrix and multiply it by a 3 by 1 matrix,
That would be 1 by 1.
I should get a 1 by 1 vector, right?
Yeah.
What is another name for a 1 by 1 vector?
A scalar.
A scalar. Good. Yeah, that relies on this idea that's kind of weird. That if you think about R1 as a vector space, it's the same thing as regular R. And scalar multiplication is the same thing as regular multiplication, which is real weird. Um, yeah, this is a kind of an oddity that's a lot of fun, actually. All right, so yes, you can think about this as a 1 by 1 vector, or you can think about it as a scalar. I don't care which. They are the same in this case. Okay, so let me consider this thing about, well, solutions to ax equals 0. Uh, okay, so what does it mean here that this is dot product of x and the vector 145 is equal to 0? What does it mean when the dot product between two things is 0?
Perpendicular.
Good, it means they're perpendicular. Now, how many free variables do I have here?
3.
Like if I actually multiplied this out, right?
I just realized once you get a plane,
Yep, I'd
it's like
get
a plane.
1x plus 4y plus 5z equals 0,
Okay.
which is an equation with two free variables, right? Alternatively, I could think back to Calc 3 and realize that this is a plane with a normal vector of 1, 4, 5. If I haven't had Calc 3, I'm just going to have to kind of trust that this is the equation of a plane. Okay, so I believe that they lie on a plane. And what are they perpendicular to?
The vector 145.
The vector 1, 4, 5. and the columns of A are only in
One-dimensional space?
1D space.
Okay.
Yeah.
Once I saw that it was a plane, I think all the other questions kind of locked into place.
Yeah, this is kind of a funny question because, like, okay, so if I write the dot product out like this, it's not really obvious what the hell is going on. And either approach would be okay. You can either kind of notice that it's the dot product of something in a vector in 3 space, or you can just multiply it out and notice that that's the equation of a plane. You guys with me on that? Okay.
The next one has a similar question with dimensions.
The next one is number 28. Okay. I'm going to